Welcome back, Algebros. Our final adventure for the world of quadratics is going to be solving quadratic equations. What that amounts to is as follows. You're given some kind of quadratic expression of one variable, something with x squared and maybe some x's in it, some sort of expression with all of those, equals 0 or some constant or something like that. How do we find the possible values for x? That's what these next few lessons are going to be all about, because I'm going to teach you 3 ways to go about it. The first one, simply by using square roots. Now, it's important to establish one thing. When it came to linear equations earlier this year, we saw that they could either have one, no, or infinitely many solutions. In the case of quadratic equations, so these were for linear, for quadratic, they actually have the option of 3 once again as well, but this time for 2 solutions, 1 solution, or no solutions. And in this lesson, you'll see some basic examples of how those manifest. You'll also see those later. But for right now, how do we figure out these solutions if we just don't have an x term? We saw before that some quadratic equations could look something, let's say x squared plus 2x plus 1 equals 0. That one has an x term right here. So we can't easily find, using square roots, what the solution or solutions are. However, if something only had an x squared term, something let's say x squared minus 1 equals 0, that's fair game, and we can find x solutions with just some square roots and some basic not order of operations, properties of equality. And let's see how. We write the equation as x equals p, in which case p is a real number, and then we take the square root on both sides. When we do this, we also must add a plus or minus sign, with a little bit of a warning that if our number p here is negative, then we're not going to have any real solutions. So let's have a look at what that amounts to. This equation right here of x squared equals 25 is precisely in the form of x equals p. In this case, p is 25. The first thing I need to do is take the square root on both sides, which is what happens right here. Square root on the x squared and square root on the 25. Remember that square root, the logic behind that is what number times itself will give you the number on the inside. In the case of 25, we'll see that in a moment. However, when we have a square and a radical, or the square root sign, those actually cancel out, hence the slashing. So we're left with x on the left side. Regarding the square root of 25, it's fairly obvious that 5 times 5 will give you 25. It's some of our simple multiplication facts. However, we don't want to ignore the fact that negative 5 times itself will also give you 25. Hence the plus or minus sign we talked about earlier. So in this case, x equals plus or minus 5. And we just write that as our solution. Simple as that. A similar argument comes up if we have other operators around. So in this case of x squared minus 100 equals 0, we first must use our properties of equality in order to add 100 to both sides. The result is x squared equals 100. After we do the square root on both sides, we're going to be left with x, since the square root and the radical cancel, equals plus or minus, as this step right here says. The square root of 100 is going to be either 10 or negative 10. Hence, this is our solution. The last fully guided example right here is x squared equals negative 4. Remember the disclaimer over here in red that has a giant little exclamation point on it that says if p is negative, we have no real solutions. And that's what happens right here. You stop, you say it's negative, so there are no real solutions. Don't abbreviate with R and S. It actually bothers me a little bit. So, let's solve a couple of these for x. In this first example right here, if x squared equals 64, we can immediately take the square root on both sides. What that's going to amount to, the square root and the radical will cancel, so x will equal plus or minus, what number times itself is going to be 64? You guessed it, 8. This might require a little bit of knowledge about square roots in order to make this a little bit easier. Then you just leave your answer as this: x equals plus or minus 8. In this example right here, we need to take one extra step. If I want x squared equals a number, I have to divide by 2 on both sides. So that way this x squared is by itself. I'll be left with x squared equals 49. Same logic as before. The square root will go on both sides. And then I'm going to have x equals 7 times 7 is 49. So it's going to be plus or minus 7. Next one right here. X squared plus 40 is 121. Same logic, subtract 40 on both sides. I'm going to get that x squared equals 81. Same logic, take the square root on both sides. X will equal 9 times 9 is 81, so it's going to be plus or minus 9. And these make sense. You can replace either of the positive or negative versions into their respective equations, and you'll find that you get the same answers. So, next one, x squared equals negative 49. Our first instinct might be to try to take square roots on both sides, but the number over here on the right-hand side is negative. Much like we saw in the previous example up here with negative 4, this means that we have no real solutions. And you write this out as one full phrase. And that's it. You don't have to find any values for x, because those values are imaginary. You can ask me about that later if you want to know how those work. Next up is 4x squared minus 64 equals 0. We got to do a little bit of order of operations right here. So it's going to be plus 64 on both sides in order to move it. I'm going to have that 4x squared equals 64. Next, I'll divide both sides by 4. These are all simple ways of solving an equation, so x squared will be 16. Then we square root on both sides. X will equal, the square root of 16 is 4, so plus or minus 4. The next case is fairly similar, but let's not get too confused right here. In the past examples, we've seen ones where there were two possible solutions, the positive or the negative, and we've seen cases where there are no real solutions. In a case like this where x squared equals 0, if I take the square root on both sides, I'm just going to be left with x equals what would be positive or negative 0, but since there's no such thing, it's just 0. And this is a situation where we only have one solution, and yes, you still gotta tell me. One more example, and this is one that's going to be kind of important to keep in mind just in case you stumble upon things like this. If x squared equals 7, we have x squared equals a number, so we square root on both sides. X will equal, we don't know a square root for 7. There is no whole number that when you multiply it by itself, it gives you 7. It's going to be some weird number between 2 and 3 that just goes on and on and on forever with no pattern. In situations like this, you'll add your plus or minus to the outside and leave the square root of 7 as it is. And that is an acceptable final answer. Keep in mind to leave that plus or minus outside the square root sign. If you're struggling to recall those perfect squares, you might want to refer back to earlier in your notebook when we took notes on those in the beginning of the year. Give these U-tries a shot. I'm sure you can handle them with little to no effort.